Hey, to start off with, I have this really simple example in Visual Studio. We used this example in the previous video. So we have the base class and a derived class, which is publicly derived from base. And we have a couple of simple constructors in the base. And in the derived, we also have a couple of constructors and a toString member function. And then we have the main function. Now, if I scroll up here, you can start to think that we can have a lot more code in this single file. We can have another class that specifies the base or the derived as a friend, as I mentioned in a previous lecture. We can have many constructors, and we don't even have a destructor in this example. We can have multiple member functions and member variables as well. And that is per class, and we only have two classes in this, base and derived. Then we also have main, and of course in main we write the functionality that we want. We construct the objects that we want and so on. Just scrolling back up to the base class again. Of course, what we can do with our constructors and our member functions is we can separate the declaration out from the definition. So we can have the declaration in the class definition, and then you can have the definition of the member function outside of the class definition, outside this body, as I explained in previous lectures. To a certain extent, you are going to duplicate code in that way because you are going to duplicate the headers of the functions. That adds even more lines of code into your file. So wouldn't it be nice if we could separate things out? Imagine we can separate out each class into its own file. So base into its own file, derived into its own file. You can have other classes in their own files as well. And then you can also have main in the main file. We're actually currently in a file called main.cpp. So all we want to do is we want to remove some of the other classes and put those into their own files. Well, we can actually do that in C++. Well, that is how you would write your programs, not just in C++, but in other programming languages as well. But in C++, you have header files and source files. So I have quite a few things to discuss in this video on how we can separate these things out. Now, I hinted at some of this in previous videos, but we are going to discuss this in more detail in this video. For the next example, in the main.cpp file, all I have is the include iostream using namespace standard and then int main, so the main function. What I want to do now is I want to create another source file. So you can right click on the project, add, go to the add section, new item. And here we can add a cpp file, .cpp, or a header file. Now we'll talk about header files a bit later. You can also right click on these folders. So I'll right click on source files, add new item. Select cpp file, so that is a source file. And the default name is fine for our example, source.cpp. And I'll just add that. For demonstration purposes, and as a reminder, I'm going to add a variable in here. And just some function. Okay, so we have two things here. We have this variable called var, which I initialize to 5. And we have some function here, hello, which simply prints out hello. Okay, back in main, let's say I want to use this variable var now. I can use extern int, so I have to specify the type, and then var. And then I can do something like this. Console output the var variable. We get 5 printed out. If I remove extern here, if we build a run, we'll get a conflict. One or more multiply defined symbols found. And that's basically because we have a redefinition. So if you remember from the extern keyword, that basically means that this is already defined somewhere else in some other file and we want to use it in this file. Now what about this function right here? If I try and use it, we get an error. The hello identifier is undefined. So this will work. We can do extern void hello. Build a run and that prints out hello, and that works fine. But we actually don't have to use this extern keyword. All we need is this header, so the signature and the return type, which will match the header where the function is defined. Basically what we need is the declaration, and you can think of this as a forward declaration This basically means that the function is defined somewhere else. In previous examples, we defined those functions down here somewhere. Comment this out. And then I'll put that down here. Build and run. That works fine, prints out hello. And the same thing when it is defined in a different source file altogether. Two completely different files. It works fine. In C++, you can basically think of all functions as being extern by default. Here are some possible usage examples. We have this void hello ending with a semicolon. Okay, so that declaration, if you write it in this way, typically that would mean that the function hello is defined later in the file. Whereas if you use the extern keyword, so extern void hello, you end that off with a semicolon, so you have that statement. Typically that would mean, okay, this function is defined in another file. Now imagine if you swap those around, so if you don't have extern in the second statement, but you have extern in the first statement, of course that will be confusing to whoever reads the file. Because if you use extern in the first statement, for example, the programmer is going to expect that to be in another file, but it's actually defined later on in the file. Similarly, if you don't use extern in the second statement, the programmer is going to expect the definition later on in the file when it's really defined in another file. So for clarity, you can use extern in this way, but typically we don't even use extern with function declarations or for declarations, just because again functions are extern by default. Just another quick example, I'll remove the statement here and the statement right here as well, so we can just focus on the function. Now if I comment this out, again we'll get an error right here, and you can compile this file by going to build and compile, or you can press Ctrl F7. Okay, so you compile this file and you get one failed, identifier not found. Let's move on to the source file here, and I'll actually remove this statement as well. And let's say I make a mistake, so I remove the semicolon at the end. Again, build and compile. Once more you'll get an error. So we are compiling this particular file, and so I'll fix that. I'll add that semicolon at the end and build, compile that, and succeeded, so we don't have any errors. But if we right click on our project and we click on build that, we will have an error, because in the main file, the main.cpp file again, we have that hello identifier not found. Go and fix that again. Ctrl F5 to build and run, and we get hello. So the point with this example is we can compile these different source files, and eventually they are basically linked together to form the running program. Okay, in the next section I want to introduce interface and implementation files, or header files and source files, and why header files are useful. In this example we have the source file, so source.cpp, and also the main file, so main.cpp. And I have some function definition in the source.cpp file, just some function which I called func for this demonstration. And then in the main.cpp file, that file includes the main function, which is the entry point again for our program. And let's say we invoke that function, func, in the main function, in the main.cpp file. What do we need? Well, as we've seen, we need to do a forward declaration, otherwise we're going to get an error. In the next example, let's say we have multiple source files, so we have file1.cpp, file2.cpp, the main.cpp file, and so forth. And in all of those files, we use the function that is defined in the source.cpp file. So we have to repeat that step for every file. Each time we want to use or invoke the function in a particular file, we'll have to go and declare the function before we use it. So in file1, file2, and so on, including the main.cpp file. Okay, so let's imagine in some source file we have a bunch of definitions. We have function 1 and function 2 and so on, so we have a bunch of definitions in one file. So basically I have a library of functions that we want to reuse, right? Maybe some math library or something like that. And so we want to use one or two of those functions in file 1, and maybe one or two of those functions in file 2. Maybe we want to use a couple of those functions in the main.cpp file, and so on. So you can see the problem that comes in here. We will have to declare all of the functions before we use them in each one of those files. This will lead to a lot of repetitive work, because let's say again you use 5 or 10 of those functions in that file. You will have to declare those functions before you use them. And this is where header files come in handy, because we can simply include the declarations for the functions in the header file, and then we can include the header file using the #include preprocessor directive. We include that header file in each one of the files where we want to use some of those functions. Okay, so we can do that instead of having a bunch of declarations in each one of the source files where we actually want to use those functions. Of course, this is just a high-level illustration. I'll show you in more detail how you would go about doing this in the upcoming subsections. Let's talk about interface and implementation files. A class can be defined in files that are separate from the file that has the main function, right? And again, the main function is the entry point for our program. And we typically separate the public interface of a class from the private implementation. So the interface is the public part, which is accessible to outside code, and that's basically like the public section in your class, whereas the implementation is not accessible to outside code. This is for reusability. The programmer does not necessarily want to know how the class and how the functionality is implemented. The programmer would simply want to use the implementation, and what that will mean is the programmer will include the header, which will contain the interface and the class definition. Right, he'll include that at the top of the file in which he actually wants to use that code. And what does the programmer have access to then if he includes that header in some other file? Well, the public members. Okay, so the header file is the specification of what the class does. It's basically the interface, which typically contains a class definition, and that class definition will include the member variables and the declarations for the member functions and the constructors, the overloaded operators, and so on. And then you'll have a separate .cpp file, which is an implementation file, and that will contain the definitions for the member functions of the class. Now, the private section of the class is also considered to be part of the implementation, because if you use that file or include that header file in some other source code file that you want to use, such as the main file, for example, and you instantiate that class, you create an object, and you do the dot or the arrow operator, depending on whether it's a pointer or not, right? What do you have access to? You only have access to the public members. Now, typically you'll put member variables in the private section, and this allows us to divide the program into separate parts. You can actually compile those parts separately as well, and to run your program, those separate parts or files are linked together. Basically, over time, you create this library of classes that you can reuse, and that allows for code reuse, so you don't have to write the same code or the same classes each time you write a similar program. Similar to our IOStream, we include IOStream at the top of our file so that we can do console input, console output, and so on. Okay, we are reusing code that already exists, and similarly we can create our own classes that we can reuse. The more complex your program is, of course, it makes sense to separate things out. Back in the example in Visual Studio, let's go and create a header file. In the Solution Explorer, we can see that we now have main.cpp and source.cpp. So let's go and right-click on header files and add new item. Of course, you can also right-click on the project, add new item, and then select header file, right? Doesn't really matter which one you use. I'll call this header1.h and then click add. I'll talk about this pragma once a bit later, so for right now I'll just remove it. Now back in main, I want to remove this right here, this forward declaration. I'll just cut that out. Then I'll go back to this header file, header1, and I'll paste this in, void hello. So we have the declaration in the header1 file and the definition right here in the source file. Remember, if you have the definition, so let's say in main you have the definition up here, then of course you don't have to forward declare it. You can just use it as I've explained before. But of course right now in the main file we'll get an error because hello is undefined. It doesn't know about hello. As I explained in the slides, you can have many function definitions within a file like this. And then you can have a corresponding header file maybe with all of the headers. And then you simply include the header in the file where you want to use it. So we want to use this declaration in the main file, main.cpp. So how do we include that? Well, we use the #include preprocessor directive. And between quotations you specify the file, so header1.h. Notice that this is different from IOStream, so the provided ones. Again, IOStream is for console output, console input, and so on. That is a provided one, and this one between quotations is a user-defined file, so notice again the difference between the provided ones and the user-defined ones. You'll notice the red squiggly goes away. Build and run, this will work fine. Prints out hello. So basically with this preprocessor include, that is going to include the contents of this file, header1, into this main.cpp file. And so what that means is we now have this void hello, this declaration in the main file because we've included that entire file right here. Let's talk about including header files in a bit more detail before we move on to the next section. As discussed, you can include the contents of a header file into another file using the #include preprocessor directive. Now here are two ways of doing it. You can use the angle brackets or you can use quotes. Basically, the preprocessor has to determine where the file is located, whether it's a user-defined header file or a standard library file such as IOStream. When we use angle brackets, those are predefined preprocessor include directories. So basically the preprocessor is going to know where to look for the files because those directories are predefined or pre-specified. And I'll show you that here in Visual Studio in just a second. When we specify a file between quotes, the preprocessor is going to search local directories relative to the file that contains the include statement. And that's because those files are typically going to be relatively in the same location. And if you have a large project with a bunch of folders, right, and use those to sort your files, you have a bunch of header files, and you can also specify the path between quotes. We'll see a quick example of that in an Unreal Engine example later on in the video. In our example in Visual Studio, we include this header1.h file. You can right click on that header1 and then open containing folder. I'll just bring that up here and you'll notice where that is. Now you'll notice that we actually do not have headers and source folders in this project. They are all basically in the same folder under CPP demos. Currently this is the project name. I'll just go back here to the Solution Explorer. In the Solution Explorer you can see we have files, header files, source files, but those are just for organizational purposes. Those are not real or actual files. Just go back to main here. But the point is when we use this quoted version of the #include, firstly again that is going to search relative to the file that contains that #include statement, which currently is main.cpp. Okay, if I go to that, you'll see these files are all pretty much in the same location. Whereas the IOStream #include right here uses the angle brackets, and that is because that is in a predefined preprocessor include directory. Okay, you can think for a second. C++ provides us with a bunch of these files such as IOStream, string, the C standard library file, and much more. And of course those do not get copied over into our project files each time we create a new project. Those are basically installed in one place and we can reuse those across multiple projects, if that makes sense. Now what I can do is I can right click on the project and then go to Properties. You can also go to Project up here, Properties, and then click on VC for Visual Studio C++ directories, and then you have a bunch of things here. We have include directories. Don't worry too much about what all of this means. These are just a few path specifications. I'll just click on this drop down and click Edit. You don't have to do this yourself. I'm just demonstrating this to you out of interest. So at the top here we have this one right here, Visual Studio 2019 Community / Visual Studio Tools MSVC and so on, ending with include. I'll just go out of this for now and I'll right click on IOStream and I'll go to the document IOStream, and this is the IOStream standard header. You can look through this if you are interested. You have C in, C out and so forth. What I'll do now is I'll right click on that IOStream that typically opens to the right, and I can open containing folder. Okay, scroll down and you can see the file. This does not have an extension such as .h or .cpp. .h is typically for the C language headers, and to differentiate those, the C++ files typically do not have an extension, so we just have IOStream, and that is in the same path if you follow the breadcrumbs: Microsoft Visual Studio 2019 Community, Visual Studio Tools, MSVC, 14. something, and then include, and then we have IOStream. I'll just scroll down here. You have other ones as I mentioned, you have string, and a bunch of other ones as well. Going back to Visual Studio, again I'll go to my Properties, Include Directories. I'll just go to Edit again. And you'll notice that that path is basically the same. So these are predefined include directories. There are a couple of those here. Windows Kits \10 include and so on. And I'll just do one more example. Close this file off. Maybe this one, stdlib.h, and I can right click on that, go to document, and right click again, open containing folder. And if you follow the breadcrumbs again, you will see Windows Kits \10 include and so on. And here you have stdlib for standard library. This again includes that random function and so on. You have a bunch of other ones here as well. And then you also have the one without the extension, so cstdlib. This makes it clear that it is the C standard library. This again includes general purpose functions for random number generation and so on, but this is the one that you'll typically use in C++ because it does not have the .h extension. Again, you can right click on that if you want, go to the file, right click, open containing folder. And this is in the first directory that I showed you, Microsoft Visual Studio 2019, Community, VC, Tools, and so on, ending with include, cstdlib. This is the same file that has that iostream file right here. And you'll see many of these do not have the .h extension, because they are basically the newer C++ versions of those files. I'll just remove that. Now let's say we try and do something like this. Okay, let's try and do something like this with our user-defined header file. You will already see a red squiggly, cannot open source file header1.h. Ctrl B to build. Cannot open include file header1.h, no such file or directory. And that's because this is not included in a predefined directory. So for our user-defined headers, we will use the quotes. You can actually use quotes here as well. So for iostream, for example, you can use quotes like that, and I can build and run, and that will work fine. But where a file has a predefined include directory, we're going to use the angle brackets, right? And then for our user-defined headers, we use the quotes. Okay, as I mentioned in the previous section, when you do this #include and you include a header, that is basically going to include the contents of that header into this file, so in this case into the main file. Now that can lead to certain issues, and we'll talk about those in this section. Let's forget about this function for just a second, and I'll define this class entity. It doesn't really have anything in the body for right now, but that's fine for this example. And I'll go back to main. I'll just remove this right here for now. I'll go and right click and build to build that project. And you'll see it builds successfully. Now what happens if we include that file multiple times? Okay, so I include header1.h twice. Remember, that is going to copy the contents of this file into main twice now. So if I do Ctrl B to build, we will get an error. Entity class type redefinition. So if you include it only once, it works fine, but if you include it twice, of course, we're going to get a redefinition error. Of course, you'll get the same error if you try and build and run your program. Okay. So we've seen that including that file twice will give us an error. So I'll just remove the second include. Ctrl B to build, and that'll work fine. That'll build successfully. Again, if you forget the shortcuts, you can click on build, and you can see the shortcut right here, Ctrl B. Or you can just press Ctrl F5 to run it, of course. Okay, let's go and create another header file now. Right click on header files, add new item, header file. I'll create a header file called header2.h, and I'll add that to my project. Once again, I'll remove this. I'll talk about this here in just a second. Move my tabs around a bit. We have header1, which includes this definition, class entity. So I want to include that into this file. So I include header1 into this header2 file. What does that mean? Well, it's going to basically copy and paste the contents of header1 into header2. So basically header2 now also includes this right here, class entity. Back in main, Let's do this now. We include header1.h and header2.h. If we try and build that, again we'll get failed. Entity class type redefinition. Okay, so make sure that you understand why we have this problem. Again, back in header1, we define this class called entity. We include that in header2, okay, using the preprocessor directive #include header1.h. So both of these are going to include the entity definition. And then we go and include both of those in the main file. And that is why we have a conflict. So how can we avoid these redefinition errors, and how can we avoid including the same thing multiple times? Well, that is what I'm going to discuss in the next section. To prevent multiple inclusions, we can use what is known as include guards. And with these, we can basically wrap the code in a header file in an include guard to prevent multiple inclusions. You can see an example at the bottom of this slide. That first preprocessor directive, if ndef, that is basically going to check if a symbol entity_h is not defined. You can use any valid identifier name for the symbol. In this case, I chose entity_h because it's going to be in a header file, and also because we are wrapping the class entity in this include guard. Now, if that symbol is not defined, then we can define it and include the file contents. So we define that symbol using #define entity_h. That symbol is basically placed on a list and will now be defined. Then we have whatever code it is that we want to wrap, in this case class entity. Right at the end we have #endIf. Now if the symbol is already defined, then of course it's going to skip the definition of the symbol and also the content, so it's going to skip all the way to that endIf. But again, if it's not defined, then it's going to include everything between the #define and the #endIf, and it will define that symbol. You can only have that symbol once. It's in the global namespace, and that means if you have the same symbol in another file, you can have a conflict, and I'll show you that in an example in Visual Studio here in just a second. Another way of preventing multiple inclusions is to use the pragma_once preprocessor directive, and that's also going to ensure that the file contents are included only once. The benefit of this is that it does not pollute the global namespace with a symbol, and because of that it also can cause symbol collisions. We have an example at the bottom of the slide. We have pragma_once, and then whatever code you want in the file. So in this case we have class entity. Now this pragma_once is actually not part of the C++ standard, but it's supported by the common compilers. Other obvious benefits is that we have to type less. We only do that pragma_once, we don't have to do the if not defined and all of that stuff, and then the endIf at the bottom of the file, following the code that you actually want to include. So for the most part you will be using the pragma_once preprocessor directive. Okay, I'm back in Visual Studio in the main.cpp file. If I do Ctrl+B to build, I will get a failed, because again we have header1.h included in header2. Okay, we want to prevent multiple inclusions, so what we can do is one of two things. We can okay, so this is the include guard. If not defined, if the symbol is not defined, then go and define it. So we define header1, and then we can include the contents in the file. Otherwise, if that is already defined, then we skip this entire part between define and endIf. And then in header2.h, I'm still including header1.h. So back in main, can now Ctrl+B or Ctrl+F5. I'll just Ctrl+F5 to build and run. This runs, we get end of program printed out, and succeeded, we don't have any errors. Now there is one problem with this. I'll just go back and I'll copy this, and in header2 I'll just go and remove that. So I'll paste over that. Remember, in the source.cpp file we have this hello function defined, so I'll replace this right here with the declaration or the prototype for that function. And then maybe in main I want to use that, so I include #include header2.h, and then in the main function I want to use that, and you'll see we get an error. Identifier hello is undefined, and the reason why that is because if you go back to header2, it uses the same symbol, which is header_1. That is typically in uppercase. You can see we have a conflict here between header1, this symbol right here, header1, and what we have in the header2.h file, which is also header1. You'll notice that it is sort of grayed out. The code in Visual Studio is sort of grayed out. close that down, and you will notice we have inactive preprocessor block. Okay, so this code right here is never gonna get included in the main.cpp file, and that's why we get an error in main with this hello function call. Of course, you can go and change that. And if I minimize that, you can see active preprocessor block, and it's not grayed out anymore. So back in main, we no longer get those red squigglies. And if I build and run, it should print out hello, and then end of program. And of course, we can avoid all of that hassle altogether by removing all of this, and this end if as well. And simply do pragma once. The same for this right here. And back in main, Control F5 to build and run, and that works fine. Prints out hello, end of program. And it is much less typing with pragma once, and because we do not define a symbol in the global namespace, we cannot have a conflict with that. It's often the case that programmers copy files around to reuse existing code, and in that case you can get conflicts with the include guard symbol, so use pragma once instead. Next, I want to delete those example header files and create a header file for a class. But before I do that, I want to talk about dependency, because whenever you delete a file or a header file, you want to make sure to check and make sure that there aren't any files that are dependent on that file that you are trying to delete. So what is a dependency? Well, a dependency exists if one file, typically a .cpp file, uses another file, right? And what do we include in .cpp files? Well, header files, .h files. We have compile time dependency, and that is when you must include some header file into some source file for compilation. And then you also have link time dependency, and an example on that is when you have a file, let's call it file2.o, some object file. That file contains symbols that are defined in file1.o, which is also an object file. Another thing that often happens is you make changes in the interface file, and that will require changes in the dependent.cpp files. Another note is that you should not use #include in a header file if a forward declaration will suffice. The reason being is that when you #include a header file, let's call it header.h, that header file, again header.h, may #include other headers. The dependency grows in this way and can often be avoided by using forward declarations instead. If the definition of some class, let's call it class A, contains a member variable of type class B, or if class A contains a member function that returns an object of type class B, or that has a formal parameter of type class B, then the header containing the definition of class A must #include the header with the definition of class B. Also, if class B derives from class A, the header containing the definition of class B must #include the header containing the definition of class A. Let's say class B publicly derives from class A, but you don't include the header where class A is defined. That doesn't make sense, right? You need to know what class A is in order to use it and to extend it where you define class B. Here's a quick example. I have a player.h file and a main.cpp file, and in the player.h file I do the pragma once, and then I have a struct vector, which is a forward declaration. Okay, so make sure to end that off with a semicolon. That is simply a declaration. This will allow us to use pointers and references to that vector type without having to include the header where that struct is defined. That means we avoid that dependency. We don't have to include that header file where the vector struct is defined. Following that, I have the class player definition, and in the body I have a location, which is a pointer to a vector, and that is fine. The pointer is going to use the forward declaration, but the next statement is going to give us an error because that is a member variable location, so it's an object. But the struct vector that we use is just a declaration, it's not a definition. So we are trying to instantiate an object from an incomplete type, and because of that we'll get an error. And then in the following statement, we have the sprint location function, and as a formal parameter that has a reference to a vector, and that reference parameter uses the forward declaration as well. So again, when you have a reference or a pointer to a type of vector, then that is fine. But if you have a pass by value function, let's say pass by value instead, so you have vector loc for location, that would also give you an error, but in this case it's fine because we are passing by reference. Back in Visual Studio, if I go to header2.h, we have this void hello declaration. So if I go back to main.cpp and I comment that out, or actually I'll just remove it, of course this hello function again will be undefined, so we'll get an error. That again is because we don't have that forward declaration anymore. So basically with this right here, with this header included, this file main.cpp is now dependent on header2.h. Okay, that is where the dependency is. Now I'm going to remove those two headers and I'm going to delete that function as well. So I want to move on. I want to delete these files, header1, header2 and the source file, and then I want to create a new header file for an entity class and a corresponding source or .cpp file for the implementation. So in the Solution Explorer, I'll just go and right click on those files and remove. Then you can choose if you simply want to remove it from the project or whether you want to delete that file. Now in this case, I'll just click delete. I won't be using that again. Right click on header2 and I'll click remove. And once again, I'll just click delete. If you choose remove, you can always just add it back later. But again, I'm not going to use it again, so I'll just choose delete. And the same for the source file. I want to keep the main.cpp file. Source.cpp currently contains this hello function. Okay, so we don't need that anymore. And I'll right click on that, remove, and delete. I'll just click on save all again. Ctrl F5 to build and run, and all we get at this point is this end of program that prints out because of this statement. Okay, now I can go and create new files. So in the header file or the source file, you can go and create those, or you can right click on the project, go to add, and then you can add a class as well. That will bring up this dialog. You can use this if you want as well, but I'll just go and do this manually. So in the header file, I'll right click, add, new item. I'll choose header file. I'll call this entity.h because I'm going to define a class in there called entity, and then click add. Okay, we have this entity.h file now. We have pragma once to avoid multiple inclusions, and then we have this entity class definition. In the body, we have in the public section, we have a constructor, and we have this toString function, and then we have a private section. I just do int member, or just some member. You'll notice we have these green squigglies. If I hover over one of those, function definition for entity not found, same for toString, definition for toString not found. So what I'll do is, in the source files, I'll right click, add, new item, C++ file, so .cpp file. I'll call it entity.cpp. Your files typically match, so your header will be something like entity.h, and your source file will be something like entity.cpp. Just click add. You'll see we don't have any members available, and that's because it doesn't know what this entity is. So what we have to do is we have to include that header. We include that header entity.h. Now it knows what the entity is. It has already seen the definition. Now I'll see I have access to the members. So I'll do toString. So I'll have to include the IOStream as well and then use the namespace standard. I'll just do it like this. And then we also have the constructor. Now I'd like to show you a quick way of doing this. You can right click on it, select quick actions and refactorings, and then click create definition of entity in entity.cpp. Then Visual Studio will typically bring up this window. This is a peek window, so we are peeking into entity.cpp. You can click this right here to promote to document, and basically that's just going to take you to there, or you can just click on the tab, so entity.cpp, and you'll see that it defined the function for us. And that can be really handy, especially if you have many formal parameters. As you can see, it adds everything for you. All I have to do now is add the member initialization list. And that is it. I'll just move my header to the left here. So in the header, we do the class definition. We specify which members we want to be public and which ones we want to be private. And then in the .cpp file, we go and define the member functions. And again, if you try and remove this include, the entity.h, not going to know what this entity right here is. So we pound include entity.h, and we go and define the member functions by fully qualifying the name. So we do entity, the scope resolution operator, entity, in this case for the constructor, or the member function, which is toString. Okay, now how can we use this? Well, back in main, I include that entity.h file. And what does that mean? Well, we now have this class definition. So what I can do in the main function is I can instantiate that entity class. I construct entity1, pass in 5 for the constructor, and then I do entity1.toString. Control F5 to build and run. You may not have this end of program, I just added there for myself, but it prints out 5 just fine. Okay, so I hope this gives you a basic idea of how we will go about defining our classes. We will have the definition of the class in a header file, and in the definition we'll typically only have the prototypes or the declarations for the member functions, and then in the .cpp file, corresponding CPP file, also the implementation file, where again the header is the interface file. So again in the implementation file we go and define the member functions. Here I have a quick example in Unreal Engine for one of my projects, and I'm in a header file called treebase.h, where I go and define a class called treebase that publicly derives from a actor, because this is going to be an actor which can exist in my world, so it has an X, Y, and Z component. I can move it around and so forth. Don't worry about all of the details, you'll learn more about that in the Unreal Engine section if you're interested in Unreal Engine. And then we have the public section, we have a bunch of members, we have a bunch of member functions and so on. And then in the treebase.cpp, I'll just scroll up here. You'll notice that these include specify a file path and not just a file. You are going to include the treebase.h file because those include the headers. If I scroll down, I have a couple of helper functions here, such as private void change direction, for example, and spawn apple. Those need to be public in this example, so they are private. And in the treebase.cpp file, I can scroll down and I have a spawn apple. Okay, here we have the definition of the function. So again, in the .h file, you have the declaration, and then the definition goes in the .cpp file. Now I'd like to use another example before we wrap up here. This function is basically used to spawn an apple every second, but what I wanted to do was to give it some randomness, so I never know if it's going to spawn to the left or to the right of the apple tree. So I did this in a very simple way. I have a vector, spawn location, and I get the actor's current location, the tree's current location in the world, and then I do some offset based on the outcome of this function right here. Okay, so that gives us some randomness and will determine where the apple will spawn. So either to the left or to the right of the apple tree, and this is where we actually spawn the apple. But this here is what I want to draw your attention to. So if math in Unreal Engine is basically a structure for helper functions, so I'll right click on this and then I'll go to definition. And you can see this is a struct and it is in a header file called Unreal Math Utility.h, and this has a bunch of helper functions, including this one right here, for example, random range, generate a random number in a range. Here's an interesting one, for example, performs a linear interpolation between two values, so the lerp right here. So as you can see, this is very handy for creating a library of functions, helper functions, that you can maybe even reuse across multiple projects. Okay, so just a quick real-world example for you in an Unreal Engine project. Okay, let's wrap up this lecture. Just a few final notes. Never pound include one .cpp file into another. You want to pound include .h files into .cpp files, but you're not going to pound include .cpp files, right? To avoid dependencies, as I mentioned, the header file should only pound include other header files if absolutely necessary. And as I mentioned, with pointers and references, you can use forward declarations instead. That is, if you have pointers and references in your class definition, you can use a forward declaration as opposed to including a header. And in that way you avoid dependencies, and you want to use include guards or pragma once in your header files to prevent multiple inclusions. Okay, that is going to wrap up this video. It was a long one, but quite a few things that I wanted to cover here. So I hope you found it useful, and I'll see you next time.